This time on Captain Chaos's Laboratory, we're working on a Lemax piece called The Witch's Lair. This was sent in because it was purchased at a thrift store. This was sent on the paper. It says, lights come on, but no movement or sound. The witch is supposed to come out of the chimney. Never worked since they bought it from the thrift store. And that the witch that's supposed to be inside here is missing, but she probably has it at her house somewhere. I don't have any lights. I hear it clicking inside, but there's no lights, there's no movement. If I turn this, you can see this witch moving. It's on the same mechanism. So I'm not sure if something happened in shipping, but I have no lights. So we're gonna undo the power, and I'm going to take the bottom off. Now, I did heat the bottom up already, so I could save some time, but I have not pulled it out. So this is a first for me, and it's a first for you. And that's how it comes out. Not too bad. Oh, this thing is kind of messed up in here. Nothing's attached. All the mechanism is just floating around, just literally just pieces of it stuck inside. And that's where the witch would go. So normally when this happens, you have not the broken attachments, but normally when you have no functionality, it's because you don't have a good motor. Your motor is most likely shorted. So first thing I'm going to do is find out where this motor is plugged in at, and remove the motor and see if it lights up and has sound. It's an interesting mount for the motor too. I don't know where these motor wires go. Oh, they're soldered up in there. Thought for sure they'd be down here on the board. Makes sense if they were, but it's Lemax, doesn't have to make sense. The motor, there's a board up in the corner here that's it's a transfer board. Looks like it sends the 4.5 volt power up to the board, and then the board in turn transfers it to the different lights and the motor itself. So let's check the actual circuit board at the bottom. So this red and black wire here should be the transfer board. The black and white wire bypass the board and go up here. Probably a light, or lights, plural. You got lights now. You got humming. There's two motors. There's also a motor right here. So that one might be the humming one. That one right here is the bad one. And I don't know, does this even have a speaker? Yes, it does. That's on the bottom. All right. Well, this switch won't work, the one that goes up and down, because the mechanism is all jacked up. The gear is not in place. It's wedged. Everything is bent for the switch. The motor might be good, but it's wedged. I'll unwedge it by unwedging the gear. No motion. Still nothing. So this motor and micro switch or over travel switches are connected to this big plug right here. So let's pop this big plug out. See if anything else starts to work in case this motor is also bad. They got hot glue on it, so it doesn't want to come out. There we go. Speaker still humming. we'll get rid of some of this hot glue. That. Alrighty, so this flat pin connector has 6 wires, 2 for the switch here, 2 for the switch on the bottom, and then 2 for this motor. Let's see if the motor actually works. So I'm going to set my meter at, or my power supply at 3 volts here. And I'm going to send 3 volts directly to the motor and see if it spins. If the motor shorted out, the machine will beep. If the motor's good, the motor should spin. Motor spins. That sounds okay. And all the little gears look to be good. It's reverse polarity since it's a up and down motor. Oh, motor's working. This thing might have a bad circuit board. Let's do the same thing for this motor. This motor, though, we're going to have to cut the wire. So let me find the space here that I can cut the wire. Like that. Alright, we'll trim this off and we'll send power to it and I'll see if the motor spins. Hopefully it does. I think this motor just goes in one direction, and it should have an eccentric that makes the witch move back and forth. One wire. Whoa! That motor is drawing almost 2 amps. That motor is definitely bad. It's either bad or bound. But that motor is pulling some massive power. These old motors should never pull anything remotely close to 2 amps. Geez, that's almost maxing out my machine. My machine's 2 amps. It goes about 2 1/8, 2 1/4 before it trips. But it's pulling, when it was running, it was pulling 1.59 amps. These little hobby motors usually pull 1/1000th of an amp, or 100th of an amp, sorry, 100th of an amp. So this thing is pulling way more power than it should, which is bad. That means the motor may have fried the circuit board, and that's why the speaker's humming, because the chip that's on the bottom of this board might have got smoked. Unfortunately, that does happen. Let's try one more time. 1.6, 1.7, 1.4, and the machine just turned off and it'll reset, which means it exceeded 2. Alright, so we definitely got a bad motor. So, this motor here, right there, is bad. And this motor is good. This motor is not responding to the micro switches. I'm going to pull that back out. That's in the way. So, let's put this in. Check this gear for cracks. May have just come off because it was bound. Looks good. Let's set this halfway. There we go. And let's just make sure it goes up and down. It's down. That's up. So it does go up and down. Hopefully you saw the shaft move right here. I wasn't looking at the screen. Nothing but a humming speaker and white lights. That's horrible. Well, that fell out of the inside. I have no idea what that goes to. It's the same color paint as that, but I don't see anything that looks remotely close to that. Oh, it looks like a telescope? Does it have a telescope mount? Oh, maybe that was right here. There's an indentation. Well, I got a box. Let's look at the picture. It shows a windsock up there. There's the box. And there's the windsock right there. But that doesn't look like a windsock. Also, the windsock is silver, white, red, and gold. That's just gold. Oh, yeah, it is a telescope. It goes right there. So it probably got broke off and then went through the window. So the telescope goes right here. Good to know. Anything else hiding up inside this thing? Well, as far as the motor goes, this is probably one of the easiest motors to take out. It has its own little C-clamp that's pointing straight down, so you don't have to disassemble the gearbox, which is absolutely impressive. Go. And this motor is greasy, and this motor's gotten hot. You see the stickers peeling off of it? Well, at 2 amps, this motor is going to get real hot, real fast. So there's a good chance that this motor destroyed that circuit board. I actually have another one I'm working on right now. That is the Ghost Around. I'm sure you're familiar with it. The one that spins and lifts. It's a carnival ride. That the motor overdrew because it filled with grease and became shorted, and it actually burned the circuit board up. Half the circuit board is destroyed. I got everything working except for the lift. So it's got sound, lights, and spin, but no lift. And I'm going to see if we can make it lift and lower, but I can't guarantee it because that board is... that whole corner of the board is smoked. And the reason this happens is because Lemax uses a lot of grease, and unfortunately it's a little too much for most of these, and the grease, like that motor is greasy, gets into these holes and then creates a short. Sometimes the short just causes the unit not to power on, other times the short causes it to burn out. More often than not, it just doesn't power on. It's probably about 1 in every 50 that I've come across that actually has a damaged circuit board due to a shorted motor, which is almost 100% of the time caused by excessive lubrication. Less is more. You want enough to make it work, but you do not want so much that it can damage your components by causing it to short out. So I might be able to make at least the motion work on this. I'll have to probably stop the video and find a video on this piece, maybe from the Lemax website or on YouTube, of what this thing looks like when it's working. Because I'm sure it has flashing lights. I'm sure the lights just don't stay on white. That doesn't make any sense. They might. I don't know. It could just be background lights. But we're going to put this motor in and plug it back in and see if the actual mechanism, well, actually see if the unit can power its own motor. If it can, then I'll try and get the mechanism to mount back into place, which it looks like it was just glued in, which is possible because this is a ceramic piece. The plastic pieces, which I know everybody hates, they usually put standoffs so everything can be screwed down and it won't come out of place. When things get older and the glue breaks down, it falls apart, and that causes problems. Resin's about 50-50. Usually most of it is just glued in, but sometimes they resin in some sort of mount, like a screw boss or a piece of plastic or a piece of wood, surprisingly, like balsa wood that something screws into. So that way you can actually run a real screw in and you're good to go. But when it's ceramic or porcelain, you rely on glue. And glue breaks down over time, especially if it's exposed to a climate where it gets really hot or really cold. Really hot makes it expand and weaken, really cold makes it contract and crack. So and that might be why my display doesn't fail as much as others, is because mine's in the house all the time, always up. It does break, don't get me wrong, don't think I'm saying, oh, it's perfect. But I don't have as many failures as other people because I don't store mine. So in the summertime out here, when it's 110 something in the shade, like this year we got up to like 118 in the shade, in your shed or your attic, you're talking 250 degrees, and, well, everything breaks down. So being in a relatively climate-controlled house, I mean, when I say relatively, I mean I've had this house over 100 degrees when I've lost my air conditioner. I don't have too many failures. Now, I currently have a couple of pieces that don't work right now that I'll eventually get to. They're not huge issues. One's one of those ones that takes that 6-volt light bulb. I put a new light bulb in there, but the entire housing is disintegrated from age. So I just gotta make a new housing or glue it all together and put the top back on. And then I have one that has like 18 moving things, and one of the moving things isn't working, which is very common on that piece, and eventually I get around to it, but nobody notices. So, and then my speaker is blown on my hotel. The speaker sounds horrible. It works, but if you turn the volume up above a whisper, it's all crackly because the cone's blown. I bought it used, so what do you expect? But they're just things I'll get around to eventually. I'm usually too busy working on everybody else's to fix my own at the moment. And I'm not overly concerned. Hey, look, the pumpkins came on. That's because I plugged in the rest of it. The motor's spinning. Sounds great. Green lights are on. Okay, so they have the white lights powered directly off the board because they run at a much higher voltage, and they have everything else run off this distribution board, which most likely has resistors and stuff on it to power it down a little bit. So now that we know it works, I'm going to heat shrink those wires. Do it really fast with a lighter. No, we're not listening to the heat gun. There we go. And let's get this motor screwed in. different pieces. I am actually surprised at this motor mount. It's probably the easiest to take a motor out. You don't have to disassemble so much stuff. It's actually pretty impressive. And now we'll get the belt on like that. And we'll try and figure out where this thing's supposed to mount. Make it easier, I'm going to unplug it again. Unplug both. So I can get I don't know how far it's supposed to turn. I don't see any residue or witness marks or nothing. I think the glue just completely broke off. Didn't leave anything for me to use as a reference where to mount this plate, so I know what part of the arc the witch is in relationship to the motor. So I guess the easiest way to test it is let's plug it in, and then I'll just try and hold it and figure out where in the arc she is. I don't know how to glue this plate back in. Okay, so there's plenty of room. The arc that it has is way less than the arc they cut into the ceramic. So I don't have to be perfect. But what I do have to be perfect on, or as close to perfect, is that hole. If I move this too far over, you see how it moves? So I got to make sure that when this is glued in, that is in the center. Like that. That's all the way in now. So I'll use that as a reference on where to mount this. Now the arc in the top where the witch moves, you might be able to see a little bit of it in the shadows, is probably about 1 inch longer than the arm movement of the mechanism. So that way you have a little bit of play, which is kind of nice. So let's get this glued in, and then we'll play with the bottom circuit board and take a look at it and find out what's going on with the sound and why the other motor doesn't work. But if I was a betting man, I would say it's probably a bad circuit board, just because they seem to be a lot more prevalent right now. I've had a whole bunch sent in that were overpowered, meaning that the wrong voltage was applied. So instead of putting 4.5 volts in, they plug them into 12-volt adapters, and the circuit boards don't survive. If you watch the Octo Swing series, that's pretty much what happened to that one. Or the Dr. Lunatic's Laboratory from Department 56. That one got smoked because it's a 3-volt system and it had a 12-volt power supply put in. So you got to watch your powers. What I do tell some people to do, if you're unsure, is take a Sharpie and write on the bottom. Because some of these are labeled on the black mats. Some of them aren't. If it's not labeled, you can get a silver Sharpie that writes on the black mats and says 4.5 volts. Or 6 volts, or 9 volts, or 12 volts, or 3 volts. Because older Lemax was 3, 4.5, 6, 9, and 12. Newer Lemax is pretty much just all 4.5. Which is kind of nice. They've gotten it down to a single voltage, so you really can't screw it up with the accessories. You don't have to buy different heads. You can use the accessories on the 3-head adapters, or if you want to make your own, you can do 6 or 7 heads. They make adapters for the 3-head adapters to make them 5-head adapters. I know I buy them on online because the accessories draw no power in relationship to the house itself. So there's plenty of things you can do. Just be aware that if you overload it, you can burn out the adapters or damage your house. This was asked of me earlier today, actually. Do I use the 3-head adapters, or do I think they're garbage? Because the person that did it had a 3-head adapter and it burned out. If I use a 3-head adapter, I use it mostly on houses that aren't animated, because the animation draws more power. And if I do, I'll usually do 1 animated house and then maybe 2 accessories in that same display. So mine are in cubes. if you search sneak peek under our channel, you'll find what the room looks like. A video of the room in the dark and then with light, so you can get an idea, because in the dark you can't make out any of the pieces. Anyhow, so if one cube has an animated house, and I have, let's say, lit lampposts or trees, I'll use a 3-head adapter in that cube, so that way the house and those trees or lampposts or pumpkins or whatever are all lit. Done. One plug, 3 pieces, 1 cube, finished. Move on to the next one, and we're good to go. I will rarely plug more than 2 animated houses on a 3-head adapter. And if I'm doing like my cemetery or a pumpkin patch, I've actually run like 5 or 6 pieces on the 3-head adapters by using the additional splitters that you can find on eBay and Amazon. So, and that's just because those don't draw a lot of juice. Now, one thing I do different than probably a lot of people, and it might be because technical knowledge, and I've been doing this for a really long time, is I power test my stuff. One of the videos I showed you my power meter. I will actually plug each house in independently before I put it up to see exactly how much power it draws. Some of the boxes will say like 300 milliamps or 500 milliamps, but when you plug the house in, it draws 200 milliamps, and that's because they do what's called a spike voltage. They want us to, or spike amperage. When the house turns on for the first time, what does it spike to? And I'll let that sit for a second, cure, and I'll put another bead on the other side. This house, if it says, let's see, not all of them do. Not a toy. Ontario. English, Spanish, French, something. Music. It's not printed on this box. Sometimes you go onto their website and it'll actually tell you the milliamp ratings for each piece, but you can test them yourself. That's what I do, but everybody can do it their own way if you want. It's up to you. But that's how I rated my room, so I know what kind of wall sockets to install, my turn on, turn off system that turns on the sections or all of them at once, depending on what I hit on the switch bank. So I know that I'm not overdrawing or destroying, or potentially destroying everything. So I don't have it in the right position. So before the glue cures 100%, I'm going to rotate it just a little bit. Always get these things caught on the cords. So I glued it in, lining the center piece in there, but I twisted the base too far, which means that it's hitting the side and it's not traveling the majority of its arc. So I'm going to try and pull her down and do it again. Shore bonder, which is the glue I use, works really good, and if you let it cure, which I let it cure a little too long, it's really hard to take back off. That's why I like using it. It works really, really good. It's still warm, but it's dry enough or cooled enough that it has adhered in one section and doesn't want to come back off. twist. Not yet. Go. I think I got it all now. Let's get out the piece. Hopefully everybody's getting ready for Halloween, since it's, you know, Halloween Eve, with September finally being here. I look forward to September because it usually means the temperature starts to drop. Usually. Although the next couple of days from the time that this is being filmed is going to be in close to 110 again. I'm kind of getting tired of these hot days, but that's what you get when you live in the desert. I'm actually kind of used to it. My job, I work outside in the heat all day in the sun. It's a lot of fun. So when September rolls around, it tells us our hottest month is over, which is usually August, but this year was July. And we're coming into the cooler months where we... oh, there's an actual adjustment screw on this. I'll show you. This screw right here allows you to adjust the plate's arc. That's interesting. I was breaking this glue off, but I might be able to just adjust the arc and then tighten the screw down. So I'm going to adjust the arc to its maximum to the right. And we're going to tighten all the screws, because apparently they're loose. Because this one also has an arc, and it's loose. And let's plug it in and try it again. If that's the case, I shouldn't have spent all that time trying to break the glue loose. Nope. It helped a little bit, but it's still not far enough. And this sure bonder is sure bonded. Kind of nice, it's got this open window in the front. I can get a straight shot into the mount. Just need a bigger screwdriver. Apparently, before you glue it, double check it. I thought I had it where it was based on what I saw, but apparently it was off. I'm looking for a longer screwdriver. Right there. There we go. Now it's broke free. Another option is you can get in here with a heat gun and warm the glue back up to where it becomes pliable. But this is plastic, and that SureBonder hot glue, by the time you get it hot enough to melt the glue, it usually starts to deform the plastic, and I'm trying to avoid any damage to the plastic, because that's your actual mount. So now I got one little hair that's holding me in. Just one little piece. At a better angle. There we go. There we go. Alright, so realign my center hole and twist this more to the right. Realign my center hole again. There we go. Yeah, it keeps wanting to put me back exactly where it was, and I can't do that because the center hole's not lined up. Twisting it and trying to keep my hole in alignment. Sorry, I keep looking off the cameras because I keep looking down that so I can see where it needs to be. I think I got it now. I'm going to not put a bead of glue on it. I'm just going to put a dab of glue on it to hold it. Hopefully where I need it, which is right there. And then I'm going to turn it back on. So, no bead. Just a dollop, like that. Get rid of the glue string. Let it dry for a second. Make sure we didn't lose it, still in a spot. Alright, so the witch is hitting the ceramic, so let's, since it's still pliable, let's reposition this right here. Alright, that's where we need it. It's about a 1/16 of an inch off of what I had it glued in the first time. It's going through the entire arc. So I'm going to try and do this while it's running. I'm going to try and hold it in place. Normally, like I said, I get a reference, meaning that when it breaks free from its glue, the original glue is still stuck, and I can butt it up against the glue and use it as a spacer or a jig, an alignment of some sort. But the glue isn't there. I don't know where the glue went. Probably broke off, flaked off, and fell out the bottom or out one of the windows, because this stuff is brittle. So I'll hold this right here while the glue cures. And then let's make sure we still have here. Can't do it while the arm's moving. So I turn it back off. Because the glue's on the top where the arm swings. So it would swing and smack my glue gun. And that's just to hold the front. And then once that's cured, I'll tip it and put a dab of glue on this corner that's accessible. Going the full arc on the arm versus the full arc in the ceramic. Well, once I get it glued in, I'll show you. I'll hold it up to the camera upside down, or zoom in upside down. Can I get this thing in there? Yep, good. Oh, this little piece that's loose down here is what controls the doors. Well, the door. There we go. For some reason, it doesn't move the other doors so well. There we go. I'm sure these doors were designed to open out. Well, maybe they might have been opening inwards. It's hard to tell. Like I said, I'm going to have to watch a video. I think they're supposed to open outwards. That makes more sense. If the witch is coming out of it, they would open up. So the mechanism that's not attached to anything would probably attach to this bar. I'm assuming somewhere on this bar. I don't know where. I don't see any glue or indicators on where it would go. But that bar, when this pushes up, it would have to push these open, and when it goes down, it'd have to pull them shut. But it would have to be timed to work with the witch unless it glues to the side of the witch or the side of the platform. I don't know. Because with this moving up and down, if it's would open in, which doesn't make sense, it's a box, they usually open out, I would need something that when one goes up, it pulls the other thing down, and there's nothing on here to do that. Some of this broken, rotted, dried glue off. And I'm sure that piece is probably cured by now. Once it cools down, it's pretty hard, as you saw me fighting with it just a moment ago. See what it looks like. Dry, 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 dry. They're all dry. Plug it in. Make sure it works. Works. Show you it works from up here. You'll see the witch moving, and then if I pop that back in, it's even flying in the right direction. I remember working on one of these, and the red wire and the black wire were different because different manufacturer, and everything spun backwards. And I cut it and switched the wires, so the red was attached to the black, and the black was attached to the red. So that works. Now I'm going to try and show you the arc. See the arm? There's the arc. So that's the full arc right there. It's much smaller than the actual cut into the ceramic, but it does not hit the other side, so that is the full arc. And you can see that the two screws, trying to hold it, that one and that one, have a notch, so you can also adjust it if that top plate didn't break free. So this is adjustable if need be. Probably not for us to service, but for them to assemble in case they glued that top plate on in the wrong position. Because remember, we're not supposed to fix these. If you buy any animated pieces from Lemax, it says it pretty much right inside the box on a little strip of paper. So anything that's done inside these that seems to make it easier and make a difference. May have actually been working. Sorry about that. I got my radio on in here, and apparently it's still on. Yeah, off. All right. So the assembly process is all done by their ease to assemble, not your ease to repair. Sorry, I have a ceramic splinter in my thumb I'm trying to get out. Not ignoring all your watchers. I just have a piece of ceramic stuck in my thumb. So I have a ceramic splinter. Got it. Probably from right in here where this edge is cracked. Alright. So we got the top motor working. Replaced it. Belt's good. It's pliable, stretchy, good to go. Found a telescope inside. We got the timing or positioning set. So let's find out why we have no sound and why nothing goes here. The circuit board is just glued down to everything. No screws. We got glue here, and it's glued to the speaker. I love when I do that. Usually tell you to heat the glue up with a heating gun or something, but I'm going to tell you when it's around the circuit board, if you do it very sparingly, because you don't want to overheat these components. Excuse me. Normally it's old enough the glue will just break free like that, and you're good to go. Okay, let's unplug the big one again. That. This set of wires goes to the cauldron. The cauldron has flickering lights inside of it. That's the smaller plug, so we're going to pull that one out, which has also got glue on it. Probably done that so they don't pop out in shipping. There we go. But the glue's old enough I can just break it free. And let's get the glue off the corner. There we go. So there's our circuit board. There's our speaker. There's our protector, which keeps the speaker metal from arcing the pins. Oh yeah, we got some problems on the bottom of this board. So right here, the pins are corroded and probably shorted out. I'm going to zoom in. So we're going to try and clean this and see if that solves our non-functioning problem. So you see how shiny these are, and see those? And there's a little over there. That's all corrosion. Corrosion can create shorts. Shorts create problems, especially if we don't have the legs for it. So let's see what we can do. I'm just doing a visual examination of the rest of the board. I don't see anything under the hot glue. Let's see if I can peel off their hot glue. We have a broken wire, actually. That's a problem. We'll get rid of their glue disc. And that. So this wire is corroded through. I don't know where it goes. That's gonna suck. So we got 1, 2, 3, 4, 5, 6 pins that are building up corrosion. I'm gonna take a picture, and then I'll have to try and figure out where the other wire goes and what that wire is for. Could be the speaker, you never know. So, picture. It's possible because the wire comes off of this, which is your volume slash power. Speaking of that, let's turn this off or unplug it. So the easiest way to use clear corrosion is to use an old toothbrush or a cotton swab without rubbing alcohol. 91% or higher is recommended because it's 91% alcohol and 8 to 9% water. This is 99% alcohol, so it's 99% alcohol, 1% water. That's why the higher is the better, because we don't want the water, we just want the alcohol. So, as long as you don't have power on or going to this is completely safe. This is how you clean circuit boards. This alcohol is actually 91% is because it is for cleaning circuit boards. You can buy it on Amazon. I'll put a link below in case you want it. I'm going to scrub the whole board, clean off anything that's on here from dust to grime to corrosion. Then we need to see what caused the corrosion. The corrosion caused just because of a bad solder joint and it oxidized, or is it because the component above it is leaking like a capacitor? You know, try and figure out what the corrosion is caused by. A lot of the times it's just oxidized solder. So it's these 3 pins here, which are connected to these 2 wires here, which goes to the speaker. So that could be part of our sound issue. That the speaker is corroded, excuse me, the speaker contacts are corroded, causing a short, which is why they click, but there's no sound, which also is bad for backfeeding the blob chip. We also have some damage to that track and that track. And the blob chip's right here. So that strip of glue that was right here, if you were to heat it, you could potentially damage the blob chip, which is right there. That's why I said be very careful when you're heating around the blob chip. Let's see. That's your sound chip, or your amplifier chip. I'm checking the components that are soldered onto this little board here, which are your resistors, 1, 2, 3, 4, 5, 2 capacitors, the amp, and a couple of jumpers. Now I'm going to check the rest of this, look for any other damage. And I'm going to pull the speaker out and check to make sure there's no corrosion on the pins. Looks good. Now, a bad component doesn't always show in the form of a burn or problem, but sometimes you can see it's bulged or melted, or there's a black spot on it from it getting too hot. So that's all I'm doing right now. Using magnifiers, I'm checking out all the transistors, which are these things right here. There's 8 of them. All the capacitors, which these are electrolytics, and there's 5. There's a ceramic, and then we have about 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 resistors, and a couple of jumpers. And jumpers are just these bare pieces of wire that don't have anything attached to them. They just jump from one spot to another to conduct electricity. Everything looks good, so I just got to figure out where this wire goes. That's what I got to do. And that might be the reason why we don't have any sound. Or maybe that's the reason why this doesn't work. I doubt it, because it comes on. I think we have a bad chip. I'm going to go with we have a bad chip. The blob chip ceramic is cracked, or the Bakelite coating. Normally when I come across them and they don't work right, if the Bakelite is cracked, split, bulged, that's usually an indicator the chip is bad. Probably about 99% of the time that's the main cause. This one is cracked and I can actually put my fingernail in it, which means that this chip either got hot or it cracked from age and moisture got inside. And once the chip goes, there's not much you can do unless you can find a parts house that works that you can swap boards. But I'll zoom in and show it to you, and then I'm going to probably pause the video. I'm going to let the owner know, and I'm going to try and research where this wire goes first. and then we'll go from there. So let me zoom in. And will it focus? Slowly. There we go. So grab a pointer and where is it? That right there. You can see with my screwdriver, I can, I'm trying to block the reflection of the light a little bit. This whitish arc right here is the light. That spot right there is a crack, and then there's a line right in here that you put your fingernail in. I have a funny feeling the blob chip went. And but like I said, I'm not done yet. We're gonna do some more testing on it first, and then right here, which maybe that's where the wire goes, but right where my screwdriver tip is, this track is gone. It's completely removed from the board right there. I don't know what it goes to. I don't know what it's supposed to do, but we got these tracks which are here. This might be a top track which goes a component on the surface, but we got good, 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 bad, damaged, good, good, good. Something happened right in here, and something happened to this. And it could be age, moisture, wrong power supply, dust, critter, arced this. This with the glue pretty much insulated it from the speaker over here, there. But something damaged this track, destroyed this track, unless they intentionally meant to rip it off the board, and then cracked that chip right there, right there. So that's where we're at. I might be able to make it mostly functional. Probably won't be able to get the up and down to work, and possibly not the sound, but I'm gonna see what we can do. You never know. Miracles can happen. Go back out. So I'm gonna do some tracing for the wire that's loose. That's right here where my finger is. I don't know if you can see it. It's really small. You know, over the speaker you can see it. And then I'm going to start tracing these tracks and see where this damaged one goes and where this broken one goes, and go from there. But I have a very big sneaking suspicion that we have a bad blob chip which has failed, and 99% of the time when a blob chip fails, it takes out one or two things. One is the sound. Almost 100% of the time it fries the sound, and I do not know why, but something in the blob chip circuit always takes out the sound. The second thing is if it runs micro switches like these, or over travel switches, or stop switches, there's like 18 names that people use for them. One of these always fails. Not usually both, but one of them usually fails, which means the motor continually spins until it breaks, or, which might happen here, that's why it's bound up, or the motor can't spin because it's not detecting any motion. So that's where we're at. Wow, we are almost an hour into this thing, and all we did is unbind this and make sure it works, and replace a motor and reset the spot that the glue's into. So doing very good here. But I shall return. I'm gonna do some tracing, some checking, and figure out exactly what's going on. So I'll return with an answer. Be back in a moment. All right, we're back with this witch's lair. The wire, after looking at it very closely with the magnifiers and figuring out approximately where it was in the glue, it came from that damaged track right here. I went ahead and soldered it back on, but we still have no sound. Right now the speaker is plugged in. Nothing. So what I did is I found the pin out for the chip. This chip is the amplifier chip. So the blob chip has the pre-recorded noise, whatever it may be, music, speaking, sounds, etc. And I found the pin out. And pin 1 and pin 3 are the speaker. So I trace this around because this uses a volume knob. So speaker output's just a set level, and then this changes the volume. And this chip can run from 3 to 15 volts. So that's why they use it a lot in these Lemax pieces, because it's within that 12 volt range. So what I did is I grabbed another speaker. This one is a 8 ohm 2 watt, and this is an 8 ohm half watt. So I'm going to turn it on. I can hear the speaker humming, but there's nothing coming out of it. So I'm going to touch these speaker wires to the pinouts, 1 and 3, and see if this speaker makes any noise. 3 is the positive of the speaker, and 1 is the positive and 3 is the negative. Nothing. And this speaker is just humming. The blob chip isn't sending the signal to this. This has got power. If you test the incoming powers, because how this works is, this is a basic diagram of the chip. It's not accurate to where the pins are located, but this is typical for a chip. 1 and 3, which are on the left here. The top center is right by this capacitor. You know what? I'll zoom in. It might make it easier in case you guys are interested. Go there, and then we'll move this there. All right. So the indentation right here at the top of the capacitor is the top of the chip, and it goes 1, 2, 3, 4, 5, 6, 7, 8. So it goes counterclockwise. Pin 1, which is right here, and then the third one down, pin 3, is the positive and negative of your speaker. 8 ohms is the maximum it can push to without using another amplifier. Then you have your incoming power goes to pin 2, and then it's also branched off to pin 6, 4, 5, and 8. But in between those other pins for your incoming power, which is also your signal, you have resistors, capacitors. That's what all these little components are for, and so this chip doesn't smoke. Your input for your audio comes in on pin 7, which is that one right there, which also is branched off into, this classifies as hot because it's incoming signal. And so all your pins have something connected to it. Most of it is different power readings through capacitors, resistors. Your direct power is pin 2, which is the 4.5 volts you get from the circuit. And then these are reduced down by these components and the smoothing capacitor set right there. This chip, I follow the tracks down and make sure all my solder joints are good. I touched up a couple just to make sure. The reason it's humming is the chip's getting power. You're hearing the hum. Well, I don't know if you could, but the speaker's humming. You can hear the hum, and that's because this is an amplifier. If you ever watch or listen to a band, like on TV or in person, and you hear the amplifiers going, they're just humming. It's because all that power is just sitting there, but there's no input signal to override the actual static from the amplifier. Or if you have a custom car with a big stereo in it, you fire up the amps with no input signal, you'll hear the speakers just have a low-pitch hum. That's standard. So this is getting power from the circuit. So it is powered, but it's not getting a signal from the chip, which is the problem. So that is one way to test these. You can look up these chip numbers because Lemax uses a couple different ones. This is a very standard one at the time this was made. It's still a standard chip, but Lemax doesn't use the TDA chip anymore. But they still use an amplifier chip, and that's because this chip, you can see all these components right here are for this chip. The newer chips don't require as many, which is, I don't know if it's good or bad. And it might be because this chip puts a lot of feedback into the speaker with no signal, and that might be another problem. I don't know. I'm just going to speculate. So I'm getting power to the chip, but I'm not getting signal from the blob. So somewhere between here and here, it has failed. All the tracks are good. The components are good. So I bet you when this thing cracked, the internal chip is bad, which is very common, like I was mentioning before. There's nothing you can do. If you try and remove this bakelite, you'll end up wiping the chip off the board. I've tried it many a times, and all you have is the copper pad with all the little pins that it's stuck to. Because the heat it requires to separate this bakelite from the board is hotter than the chip itself, and the chip will actually dissolve. So unfortunately, that is the downside to this. So I already messaged the person who owns this piece and let them know that I can get their lights working and all the motion on top working, and this won't because there's no signal going to this either. Let me move this over so you know when I'm pointing at it. Just realize it's off camera. This won't work. There's no signal going to this motor, meaning there's no power. There's power in the circuit, but the power doesn't. I can power the circuit, as you saw with the motor, it goes up and down, but there's no power going from the top of that chip through this board to where this is, which is the problem. It's not picking up the micro switches, which is like this two and then these outer two here. So unfortunately, this is only going to be a 50% repair in the sense I can get the top two things working, but not the speaker or the standing wedge. But you can, if you have a spare speaker lying around, you can test it. I used Arduino pin connectors to do it. You can use the factory speaker loom, which is right here, and pull the wires out or shove something into the end, because this uses a 3-pin. This uses a 3-pin connector, but you can tell the center pin, there's nothing in it. It's just the outer two. They probably just did that for spacing, for soldering, so that they're not so close together, and possibly arcing. But doing a close-up examination, like I was saying, the track that comes off this top board has an indentation from the wire, and you can see when they soldered it, they actually melted the board just enough that I could find which pin it went to. So the damaged one is the one that had the wire. The blown out one, I have no clue. There's no copper there for me to test. If you trace it through on the back side of the circuit, which is 1, 2, 3, 4, 5, 6th one over, what you do is you go to this front and you look for the 6th one over. 1, 2, 3, 4, 5, 6. It's connected to the pin 6 on the sound chip. So, but the sound chip's not working. Or it should be. It's working. It's getting power. It's just not sending out signal because it doesn't have an incoming signal. So when this blob chip cracked, it overpowered and blew one of the tracks, or something got in here and blew one of the tracks. Dust can do it. It's not common. Bug, moisture, anything. The boards aren't thermally coated with anything to resist moisture or damage, and that's good and bad. It's good because it makes it easier to repair if, like, you blow a capacitor or something. It's bad because if something gets in there. But also when they coat circuit boards, they tend to build up heat. Heat is also very bad to electronics. So it's a trade-off. There's never a perfect solution. And for the price point that these come at, this is the most affordable solution, which is totally fine. So at this point, it's just reassembly. I'm going to unplug the speaker so this thing's not humming. So I'm going to unhook the speaker, and I'm going to leave this loom unhooked as well, because there's no point. Because if for some reason, let's say something shorts out a track and sends power to this, it can't reverse because it's not picking up the micro switches. It'll just either break the gearbox, or if it burns the motor out, it'll short out and the whole unit will stop functioning again, which that's not the point. We want the lights to work. We want the witch up top to work. We want the witch, meaning the one on the clothesline. And we want the other witch to fly in her circle on the stick, the pole, whatever you want to call it. So I am going to reconnect this one. I'm going to reconnect these two over here, which is my lights and my top board. I'm going to leave this big fat one unhooked, and because this one here is the lights and this piece, so we definitely want that plugged in. And I'm going to unhook the speaker so it doesn't hum. I'm going to hot glue in the white plate and glue this back to the speaker so it's held in securely, and then glue the bottom back on. I'll chip off some of this bad glue right in here so it's a nice clean fit, and then we'll test it out to make sure everything works, and then we'll look at it in low light to see the pumpkins and the lights and everything work. But unfortunately, there's not much I can do with this one beyond replacing the motor and realigning the pieces that came out in here, due to the fact that when you lose your blob chip, you lose the entire board in most cases. In some cases, you can bypass it. Let's say the lights work, but this motor didn't work because the circuit was bad. This motor just spins at 4.5 volts. You can just wire this motor into the incoming power from the switch, this cable here, and as soon as the switch is on, and that's pretty much what the circuit board does. It bypasses the components that control that motor, except for one of these capacitors, which is a smoothing capacitor, because motors are noisy into a circuit, and then it goes right to the switch. You can do that. You can actually just wire this motor directly into the power point of the switch. You don't want to wire it to the power point where it's plugged in. A lot of these houses, more modern ones, the power port's in the back of the house and not on the end of the wheel like this one, because as soon as you plug this in, the motor will start spinning automatically. So you want to be on the switch side of your circuit. So there are ways to make things work that are damaged without having the ability to fix it completely. At least make it somewhat functional so you can watch it, listen to it. Lighting circuits can be rebuilt, redone, made. If you watch the Octo Swing 4-part series or the Dr. Lunatic's Laboratory one, lighting circuits were put into it, from flashing, pulsating, and flickering. In both of those pieces, the lighting circuits were rebuilt due to damage caused by overpowering the blob chip or overpowering the circuit, because, well, voltage is great, but too much will destroy stuff. So this is where we're at. I'm going to reassemble it, like I said, and then I'm going to show you what it looks like in low light, and then I'm going to put it back in its package after I glue it all back together. I'm sure you all know how to glue. And I'm going to ship it back to its owner. Kind of sucks, can't get it to work 100%, because this would be interesting to try and make work, only for the sense that I want to figure out how it fits that door piece on here. But without this track moving for me to follow it, I won't be able to tell anybody in the future. And there's no glue on it. I do see there's a square notch in it, so I'm assuming it has to fit on something. Like there's like a screw hole here. Maybe the screw hole is what goes in that notch, and it's missing. I don't know. The only thing that fell out of this was that. I mean, the bottom was completely on. So, but it's not to say it didn't come out of a window. I mean, these windows are open. I got to glue that back down too. But yeah, it's not the best result. It is a result. It's just not the best one. So this is where we're at. And I shall return here in a few moments once I get this all back together. So we can see the lighting on it. So if this is a piece you don't have and you're interested in, you can get an idea what it looks like, and you can see part of its function. So I shall return momentarily. Alright, it's back together. If you put this back together and you take that circuit board off, make sure you realign that circuit board farther to the front, or else it'll rub the pulley. I found that out when I put it back together. I had to take it back apart and move the circuit board. You know, it's glued to the speaker, and I removed all the glue, so I had no reference point. And I glued it too far towards the back, and it was rubbing the pulley. So, just a heads up. Well, there's the top view. You can see spinning witch or flying witch, and then the witch with the going back and forth to the clothesline. And I'm going to tip it. Make sure that the spinning witch doesn't hit anything. And I'm going to lift it. And you can see inside the window the flickering cauldron. It's not really picking up the flicker too much. I mean, it's flickering. You can see it in the background where it's flickering off the walls. Pumpkins are bright. They're not that bright. You can make out the faces like on that one there. So I have no idea why those are so swamped. But lights work. Motion works. So the only thing we're able to do is diagnose half of it, meaning it's got a bad blob chip because it's cracked, which unfortunately when they crack, that's usually the end of their lifespan. Which got rid of the witch here. I closed the door so it's not so obnoxious, but the light still does shine through. Really bright on the camera, not in person. The cameras, like I said, pick up a lot of LEDs, way brighter than they actually are. Like these pumpkins. They're not that bright. But the camera says, oh my god, they're overpowered. They're not. But anyhow. So the mechanism's disconnected, the speaker's unplugged, and that's just in case something shorts out and it causes the motor to go into on, and it can't reverse. It'll burn out the motor or break something. And then if it burns out the motor, it could burn out the rest of the board or causing it to malfunction again because it's a short, most likely. But we were able to replace the motor that was pulling nearly 2 amps. Like I said, these motors pull a negligible amount, 100 milliamps at the most. Most of them are even lower than that. So we were able to replace this motor down in here, which makes the witch spin and the clothesline witch move back and forth. We were able to remount and adjust the spacing so that way there's no binding pieces, and I was able to glue on the, I'm going to turn the light on so you can see. Light. There's the telescope glued back on. A little dab of super glue. Bottom is glued on. Now, I said some of these give you amperage ratings. I don't remember if I said it earlier in this video or a previous video because I'm doing so many of them at the same time. A lot of times it's printed on the box. I think it was this one. It's printed on the box. This one's actually printed on the bottom, which is strange. I don't have too many that print on the bottom. So I'm going to show you. .5 volts, 700 milliamps is what this is rated for. Doesn't mean that's what this is drawing. That's just what it's rated for. So that way, if you're using different adapters, you can make sure they're within the power range. Like this is what I'm using. This is the one I usually use in here. This one is rated for 1000 milliamps. And you can't see it because it's swamped out by the light because it's white. You might be able to see it there. That's 1 amp for general terms. So this only can put out 1 amp before it gets hot and or burns out. And that motor in here was pulling close to 2. Just to give you an idea. If this would have kept running and that motor kept over drawing or over amping, your AC adapter would have smoked. And if you would have had a 3-headed one, they're usually all 1000 milliamps or 1 amp. Not only would it have burned that out, but the other buildings attached to it would no longer light up. Doesn't mean they're damaged. It just means that this is going to go where the power is going to the most, which would be the one that has a bad motor. So that is that. So you can, what I do is I have a file that I put all my pieces in and I put down their amperage draw. Now if it doesn't have the amperage draw in the box or on the instructions or printed on the bottom, I use the machine I told you that tells me how many amps each one of these draws through a 4.5 volt adapter. Now all my AC adapters are 1 amp. I don't use the 800 milliamp ones they do now. I usually have a tendency of getting rid of those, giving away or stuff like that. They're good, but I always want to make sure I have a lot more power potential than I need. So that's just the way I do things. Also, my display's up all year round, and I don't really want to refish wires if the adapters fail. Now, one thing Lemax did with the adapters that I do appreciate is the quick disconnect. I know this sounds horrible, but if this breaks, I can make my own, so can you. You can buy these adapters. And if this head burns out, I don't have to undo my entire display to fish this wire through. I just replace this. Pop the new one in, cam lock it, good to go. So there are pros and cons to everything. That is more likely to get corrosion on the contacts, and you know, if you open it, close it a million times, you'll wear it out, it won't fit right, and it'll be loose. With the same token, if the head burns out, I don't have to disassemble my entire display to fish one wire. So that's it. That is the Witch's Lair, the best that I can do it on what we have available to us. It's good enough to ship back. The base is glued back on. It's not quite centered, which I just followed the glue line, so apparently it wasn't centered or it had shifted at some point. I can trim that with a pair of scissors or an X-Acto knife before I ship it, but the base is glued on. Everything is aligned. The witches work. This one won't, and no sound. But at the moment, it's as good as I can get it without finding a parts one that's broken, but the board works. So All right, well, thanks for watching. Till the next one, have a good one.